So good to see all of you. Thank you so much for coming to this amazing event, the UC Grad Slam. My name's Catherine Newman, and I have the honor of being the system-wide provost. 180 seconds, that's all they get. Ask any academic what you can do in 180 seconds, and the answer will be usually not much, but these folks are way ahead of us. Every single student who's going to be presenting to you today will have to give you complex, cutting-edge ideas based on their research in an engaging manner in 180 seconds. And that's both the challenge and the fun of the Grad Slam. And imagine what it would be like if all of us could do that in just 3 minutes. Now, you should know today that all of these amazing people are already champions. They have already triumphed by winning their campus Grad Slam competitions. So more than a competition or a contest, today is really a showcase of everything the University of California provides in the way of innovation and especially the value of graduate education. This year, all of the system-wide finals are Ph.D. students, and that gives me an opportunity to highlight that academic graduate education is the very foundation of the University of California's extraordinary success as a world-class research university. UC, as you all know, is the country's leading academic research institution, and it is the research arm of the state of California, which is why we're happy to have people from the governor's office here today. UC's role in training the next generation of researchers is a centerpiece of our academic mission. We produce highly skilled, analytic, extraordinarily insightful professionals, and they help to drive the modern economy of California and help to shape the whole world in countless ways. And as the Chief Academic Officer of the University of California, it's my great pleasure and honor to lead and advance that mission. Our commitment to and the outcomes that we seek for research, for teaching, and public service, those are incredible assets to the people of California. Our mission serves the needs of the nation in every sector, including national defense. Because of UC's role and my role as provost, I am here often in Sacramento to advocate on behalf of UC at the state and national level to help resource our efforts while highlighting the incredible return on investment that UC delivers to the state and the nation. Well, knowing what I know about our talented graduate students, if I could take 10 of them, actually these 10 would be fine, with me wherever I go, I think I could probably sit down and let them just take the way. But one of the reasons why I love this event so much is that we get to showcase just a little bit of what our students are up to and how their work impacts this society. If we can quantify and measure a lot of the value that UC delivers, then there are some aspects of what we do that are just truly immeasurable, and you get to hear about some of them today. Whether you're watching online or you're here in the Sacramento Center where we have a great audience, I'm so glad you decided to slam with us today. So get ready, buckle up, you're about to see a journey and firsthand the impressive array of impactful research that takes place across the UC. And I hope you are all as excited as I am to hear about their accomplishments. Before they get started, I have the honor of introducing President Drake, and this might be one of my last opportunities to do so in a public setting because he's taking his leave from us after an extraordinarily distinguished career as a leader in the UC system for many, many years, and most recently as our president. He became the 21st president of the University of California in August of 2020, and he oversees this world-renowned system of 10 campuses, 6 academic health centers, 3 nationally affiliated labs, and more than 290,000 students and 230,000 faculty and staff. He is also one of our main links to the Board of Regents, and I want to especially welcome the chair, Janet Riley, who's been an extraordinary supporter of this entire effort, and we're grateful to her. President Drake also holds faculty appointments at the UCSF School of Medicine as a professor of ophthalmology, and at the UC Riverside School of Medicine as a professor of medicine. He received his bachelor's degree from Stanford University and his MD and residency training at UCSF, and then spent more than 25 years on the faculty of UCSF School of Medicine, ultimately as the Stephen Shearing Professor of Ophthalmology and Senior Associate Dean. And he still has a long career ahead of him back in the university ranks as a faculty member in medicine and in ophthalmology. And I just want to say personally how grateful I am to him for his leadership and for giving me the opportunity to serve all of you. Please welcome Michael Drake.
Thank you very much, appreciate it. Oh, good morning, thank you. Thank you very much, Catherine, really appreciate the kind words, and nice to see all of you here today. This is always a very, very exciting event for us. The Grad Slam is one of our favorite events of the year, and pleased to have you all here with us today. And it's a great chance, as Catherine is saying, to bring our students and supporters of the university together, and for our first time to be able to do it here in Sacramento at our new UC Sacramento Center. So that's really, really terrific, and pleased to have you participating. The 10 grad students that we are about to meet are all winners. They've all each won a campus Grad Slam competition already. And so actually, I just would like to pause and give them all a winner's applause at the beginning. So great. I think if I won a campus competition, I'd take my trophy and never mind. But anyway, it's great to have everyone here for another round, and it's really a great thing to be able to participate in, and you'll see how impressive they are when we have a chance for their presentations in a few moments. We're going to start, though, by introducing our judges, and actually our judges are going to introduce themselves. I'll start with our Regents Chair, who Catherine just mentioned, but Janet, if you'll introduce yourself and then pass the microphone down. And you're introducing yourself for our audience here, but also our virtual audience, which is on camera. Great.
Thank you. Well, thank you very much. Good morning, everyone. My name is Janet Riley, and I'm the chair of the UC Board of Regents.
Good morning, Laurel Rosenhall. I'm a journalist with the New York Times based here in Sacramento.
Good morning. My name is Riley Johnson, and I am a sophomore at C.K. McClatchy Senior High School.
I might have to say, excuse me, go Lions. Okay, keep going.
Hi, everyone. I'm Michael Wiafe. I'm one of the governor's assistant deputy cabinet secretaries.
Good morning, everyone. My name is Ahmet Palazolu. I'm a professor of chemical engineering at UC Davis, and I'm also the vice chair of the System-Wide Academic Senate. Thank you.
You know, I haven't been vice chair of the Senate, and I haven't been a New York Times reporter. I haven't been the chair of the Board of Regents, haven't been a cabinet secretary, but I have been a sophomore at McClatchy High School, so that's a really good thing. So I like that. Anyway, in addition to the judging that our judges will do and the presentations you'll hear, we have something that we do every year, which is special, which is a People's Choice Award. And that is, at the end of the day, we'll have a vote from all of you on who you thought did the best job of encapsulating and presenting their research to you. So as you're going through and listening to all of the presentations, kind of make a note in your mind of who you think really would rise to the top of that People's Choice Award, and we'll have that at the end of the day. But now we'd like this. My notes say, without further ado, and I'm thinking I've given a lot of speeches, and they've always been without further ado. Maybe this might be my last time for a little further ado. The further ado is actually, as I look out over the audience, it's great to see so many of you I've met in different parts of our interaction with the university and with the state of California, and appreciate all of you and all that you bring to the enterprise, and happy to have you joining us here today. And now, without further, the research the graduate students will be talking about today represents years of hard work. From wherever you are, please give each of our contestants a warm welcome and a warm round of applause. And now I'd like to welcome the first contestant to the stage. This is Casey Vanderlip of UC Irvine. Casey?
Alzheimer's disease. While we hear a lot about it, what we don't hear about is how it starts. That's because it starts silently. It attacks our brains for 10, even 20 years before symptoms arise. So by the time we realize it, it's often too late. There's been irreversible damage done to our brains. This happened to my grandfather, and I wonder, if we had known sooner, could we have done something? So, Early detection is critical. And now there's ways we can do it. But there's a catch. You go to the hospital. You get injected with drugs. You get brain scans. Then you get bills for up to $10,000. Bills that insurance companies won't cover. This is a serious problem because every single person is at risk for this disease. So how do we make early detection more accessible? This is where my work comes in. I'm developing a low-burden tool for early detection. I believe there are subtle changes in a specific form of memory that's an early indicator of disease. So what am I talking about? Well, let's say you go to your favorite grocery store. On the way out, you know where you parked, left side next to that tree. But that's not very easy because you parked in many different spots in this exact same parking lot. How do you know? Today, you parked right there. Well, luckily, we have structures in our brains that work to take very similar memories and make them more distinct. But these are the exact same structures that Alzheimer's disease attacks first. So early in this disease, these similar memories can start to blur together. So we designed a game that taxes this specific form of memory. It takes 5 minutes and on your phone at home. We tested it in a few hundred older adults, all of whom had seen doctors who were told, "You're doing great. You're showing no symptoms." But those brain scans, those told a very different story. About a third of these people were already showing signs in their brain. In our game, well, our game tells who those people are. Not only that, it tells which people would develop symptoms in the next 2 years. And what's incredible is our little phone game did better than those $10,000 brain scans. This is the future we need to get to. One where early detection doesn't require injections and bills for $10,000. It requires 5 minutes, your phone, and you at home. Because the earlier we can go and find this disease, the earlier we can go and fight it. Thank you.
So Casey, a couple of things first. Work of art for the wall. Here we go.
Wow. Thank you.
Great. Take a picture there. Great. No, they'll take a picture there too. We can do one for you. No, okay, this is good. Anyway, appreciate that very much.
Thank
Congratulations. And thanks for being first. I have a couple of questions. So you mentioned your early interest in Alzheimer's disease. What were you thinking of for your career at that time when you kind of were making these decisions? What other things were you thinking about?
Yeah, so I was really interested in Alzheimer's disease, and I was like, I want to do research. Also want to be a doctor. I took the easy way out and just decided to do both. So I'm an MD Ph.D. student, and so I'm really interested in bridging that gap, and it just shows that I can't make decisions. But
okay.
Yeah.
Let me check. There was a phone app. No, I won't say that, but okay. About that. And then what is your favorite thing about conducting research at UCI?
It's really fun. The questions are hard, and it's really interesting to try to think deeply and how we can address these questions in different ways and thinking outside the box. And every day it makes me excited for what's next. So I really enjoy that.
Right. And where are you in your career, in your pathway? What year are you now?
So I've done 1 year medical school, and I'm in my 2nd year of my Ph.D.
Okay, fantastic.
So I have a long way to go.
Okay, a little bit to go, but that's great.
Yes.
And then finally, when you win a huge cash prize today, what would you spend the money on?
I haven't thought that far in advance. Probably my rent first, and then we'll go from there.
Right, okay. Well, you have plenty of time over the next half hour or so,
Okay,
so you can
great.
do that, and that'll be great.
Thank you.
Okay, thank you very much. A round of applause for Casey. And our next contestant will be Pablo Alvarez from UCLA. Pablo?
Whew, I just saved us all from Earth's deadliest animal. Not a bear, not a shark, the almighty mosquito. But if you think stopping this killer is that easy, think again. Mosquitoes are lethal because they carry viruses, the real culprits behind a deadly takeover. In over 30% of infections, these viruses take over the brain, causing fatal inflammation. The goal of my research is to stop these criminals, and the first step is to figure out how they're breaking in. You see, the brain isn't just any organ, it's the crown jewel, a high-value target, rich in resources and hidden from the immune system. So of course, it's well guarded by something called the blood-brain barrier. Think of it as a fortress made up of several locked doors, accessible only to the essentials like oxygen or sugar. This is a huge obstacle for viruses trying to access the brain, so how are they breaking in? The problem is nobody knows until now. You see, my research exploited a special twist in this story. Not all viruses in the same family can do it. Take Zika and yellow fever, close relatives, yet Zika reaches the brain and yellow fever doesn't. That makes them the perfect case study. Like a detective, I recreate the scene of the crime in my lab by growing blood-brain barrier cells and studying their interactions with two viruses, one that can invade the brain and one that can't. This led me to my first clue. Neuroinvasive viruses like Zika infect these cells way more efficiently. But how? To figure this out, I repeated these infections, but I tweaked the virus a little bit along the way, leading me to my next two clues. First, the major differences lie in the outer proteins, or the hands of the virus, which allow them to grip onto cells. And second, these hands determine how sticky a virus is. Neuroinvasive viruses have stickier hands, which help them better attach to the barrier, and that makes all the difference. In the end, I found that neuroinvasive viruses are like master thieves. Their sticky hands help them latch onto the barrier, efficiently pick the locks, and slip through to the crown jewel, while non-neuroinvasive viruses, they just can't get a grip. But my work as a detective isn't over, because we still need to stop these criminals. We now know that neuroinvasive viruses have stickier hands, but what are they holding on to? The answer is one of the many doors on the blood-brain barrier. My most recent work identified the exact door that neuroinvasive viruses are using to break in, and I proved that blocking these doors is essential to preventing barrier infection. My work paves the way for new medicines that will seal these doors off for good, protecting our crown jewel, and stopping the real culprit behind the almighty mosquito. Thank you.
Pablo, here we go.
Thank you. Photo op.
Photo op. Well done.
Cool.
Great, thanks very much.
Thank
So
you.
a couple of questions.
Sounds good to me.
Yeah, a couple of questions. So one is, what's the best advice that you've received during your research career?
Ooh, the best advice I have received during my research career. There's so many. I think for me, I mean, there's technical and then there's philosophical. Technical is follow the data. The data is the data. My PI loves to say, the data is the data. So you might have an initial thought of how you think an experiment is going and how it fits with your hypothesis, but your data could be completely different. Well, the data is the data. And so you try and you change your hypothesis and you figure out how that goes.
Great.
But more philosophically, I think one of my committee members, he mentioned, I can live with failure, but I can't live with regret. And I think that's one of my favorite quotes to use because, it's basically, shoot your shot all the time, wherever you go. You can fail and that's fine, but don't regret that you didn't do it.
Great, two good pieces of advice. I like both of them. That's great. And I like the idea, isn't it, that you would do the concept of doing research and not following the data. It's only interesting in today's world. But I almost say, I just say normally that would have been oxymoronic. And what do you wish more people understood about research science?
That it takes time. I think early on in the pandemic, a lot of people were like, well, tell me more about this virus. And I was like, well, we don't really know.
Right.
And so, and it's okay to make mistakes. A lot of people were freaking out about disinfecting their groceries. And it wasn't until way later that we learned, coronavirus doesn't transmit that often by fomites, which is just the little particles on the floor. It's mostly respiratory.
Yes.
So yeah, it takes time.
And I also learned that squash tastes really great with a little coating of bleach. I don't know if you never mind. Not true, and don't try this at home.
Doctor's recommendation.
Don't try this at home. Imagine it's 50 years in the future.
Okay.
How do you think a better understanding of antiviral immunity will impact society? 50 years from now.
50 years from now, a better understanding of antiviral immunity? I mean, we could do so much with this. I mean, you can even talk to some of my colleagues who are also virologists. But yeah, I mean, you can do personalized medicine, which I think is a phenomenal thing that we should get into and we will be getting into. You can do personalized vaccines. People always say, I got the flu shot, but it didn't do anything for me. Well, maybe it wasn't made perfectly for you, and we could do that. I think personalized medicine is a big thing that will happen in 50 years.
Great things. Okay, I appreciate it.
Yeah.
And if you had a superpower, what would that superpower be?
I think time travel, mostly because I'm late a lot. My lab will laugh about this, but yeah, I'm late a lot, and I think it'd be phenomenal to have an extra hour in the day or something.
Then you'd be late, but it would be an hour. No, never mind.
Well,
I can't figure that. There's something about that.
Yeah.
Okay, well, terrific. So I appreciate all those things, and I actually was at McClatchy High School a little bit ago and was asked questions, and actually one of the questions they asked me, my name is Drake. They said, but Drake or Kanye?
Oh,
so well, never mind. Let me say, I won't put you on the spot, but I appreciate that. So tell me about UCLA, and how did you decide on UCLA as a place to go?
I mean, UCLA is just phenomenal because, one, LA in general is you don't run out of places to eat. I love food. So you don't run out of places to eat. It's a phenomenal place to do research because the UCLA campus in general there's the undergrad campus and then the med school is right next door. There's tons of collaboration there. And I think one thing that actually stood out to me was that there's people that look like me. LA has a big Hispanic community, and I actually feel like I belong there. So it was really nice.
Well, let me say, you do belong there. Whenever you arrive, that's where you are. It's a great thing, and great to meet you.
Thank you. Cool.
No, great, yeah.
Thank you. Thank you so much.
I know that I'm going to, great. That turned out to be perfect for timing. And then our next contestant we'll welcome to the stage is Jaquesta Adams from UC Berkeley. Jaquesta.
Over the past 2 weeks, how often have you felt anxious, nervous, or on edge? According to a recent study, half the world population will experience a mental health disorder in their lifetime. Currently, healthcare providers screen for mental health symptoms using a combination of patient interviews and questionnaires. The problem is, patients often only recognize their symptoms weeks, months, or even years after they first manifest. What if we could preventatively screen for mental health the same way we do for the physical, allowing us to diagnose and treat illness earlier? The key could be monitoring how neurons, the nerve cells in our brains, talk to each other to coordinate our behavior and health and disease. And they talk by transmitting chemicals like dopamine, serotonin, and oxytocin. Oxytocin, the love hormone. It's a pop song by Billie Eilish, and it's also the chemical that rushes through your brain when you're cuddling the most precious puppy. Oxytocin communication is central to social and emotional behavior. So when something goes wrong, it can lead to disorders like anxiety and depression. How exactly different patterns of oxytocin communication connect to different conditions, however, is poorly understood. Until now, we simply didn't have the tools to listen in on the oxytocin chatter between neurons, discerning those healthy from those disordered patterns. So that's where I come in. In the Landry lab, I built tiny tools to light up the brain's chemical conversations using single-walled carbon nanotubes, or SWNTs. SWNTs are small, 100 times thinner than a single strand of hair, even smaller than neurons. And they do this thing called fluorescing, meaning they can glow in response to chemicals like oxytocin in a way we can control and measure. My graduate research has both established a systematic approach for SWNT sensor discovery and developed Nanox, a sensor capable of real-time imaging of oxytocin release from single neurons. In short, with Nanox sensors, it's lights off in the brain when there's no oxytocin and lights on when there is. Collaborators now use Nanox to understand how oxytocin release patterns change under different conditions in rodents. Furthermore, my strategy for SWNT sensor discovery can be applied to illuminate hundreds of other chemicals in the brain. This work brings us one step closer to understanding neurochemistry and its role in anxiety, depression, and other mental health disorders. My goal is that these sensors eventually allow us to see the brain ailing before we even start to see the symptoms, improving both curative and preventative mental health care. Thank you.
So Jaquesta first, work mark for the wall.
Correct.
And a photo. Okay, great, thank you. Got that? You get to keep that? And then a couple of questions for you. So what's your favorite thing to do when you're not doing research?
I absolutely love music. I love singing. I love playing instruments. So anything that allows me to do that.
Okay, and what kind of instruments do you play?
Mainly the guitar and the keyboard.
Okay, great, well, that's a good thing, and we should have given you an opportunity maybe next time.
Next time, I was going to make my presentation into a song,
Okay.
but I decided against
That'll
it.
be for next year's Grad Slam. And then when you were growing up, what did you want to be? What were your future career plans back in the childhood days?
I think it was either going to be music or it was going to be science. And I went for a career in science, but I still get to enjoy music on the side.
Okay, fantastic, good thing to do. And yes, you could have a career in music and enjoy science on the side too. So you have both directions later on. Research at UC Berkeley, what's your favorite thing about doing research at UC Berkeley?
Yes, I absolutely love Berkeley is a big campus and there's so much opportunity for collaboration, so many amazing instruments and sorts of resources available for your research on campus. I love working with my particular group of people, my lab, the Landry lab. I just really like this opportunity in science to get to do collaborative research and to be like the small part of this broader sort of study and investigation.
And how'd you pick the Landry lab when you arrived and you were thinking about your career? How'd you end up in this particular lab?
Yes, when I was first going to UC Berkeley, I didn't even know, I wasn't aware of the Landry lab. So I'm a chemist by training and I'm a chemistry Ph.D. student. But the Landry lab is actually in Berkeley's chemical engineering department. And so I just happened to be looking into nanomaterials research on campus as I was deciding what labs to rotate in my first year. And I saw Marquita Landry show up in our chemical biology graduate program, and I thought, wow, this research sounds so cool. I'm going to check this professor out, and it was just a perfect match.
Fantastic. And then what do you think the value of being able to explain research simply is? How is that valuable in the world?
Well, I think as scientists, maybe we feel a little more comfortable sometimes talking to a room of our peers and knowing like we can just kind of fall into jargon and kind of expect certain things to already be understood. But at the end of the day, while some part of science is getting the publications and kind of sharing your research with the broader science community, it's also about sharing that information with the public and the people that you hope your research is going to have an impact on in the long term, because we want people to understand what we're doing, why we're doing it, how it can have an impact on them, so that science is kind of like a welcomed and respected and understood institution for like the whole of society.
I appreciate that very much. Thank you very much. Great, congratulations.
Thank you.
And our next presenter is Yuting Ma from Santa Barbara.
It's the hottest day in summer. The AC is running, you have an ice cold beer in your hands, and you go like, ah! And then suddenly, the power goes out. Now you're sweating in the dark with no Wi-Fi. Why does that happen? That happens because the power grid wasn't ready for the surge in electricity demand. And it's happening more and more often because climate change brings us longer heat waves and crazier weather. And it's usually communities with the least resources that suffer the most. To fix this, we need to forecast electricity demand under climate change so we can build power grids that are safer, smarter, and more equitable. That's where regression comes in. a stats tool that models the relationship between weather and electricity. But I do not just use regular regression. I use functional regression. It's fancy. Let's compare stats to music. When regular regression predicts one note at a time, functional regression predicts the whole melody of the song. It takes discrete points with dimension 1 to simulate a continuous curve with dimension infinity, just like electricity demand in real life. My realistic simulate data will explore how climate change impacts the power grid in each California county over the next decade. I want to help to make sure that nobody will be drinking warm beer in the dark with no Wi-Fi. Thank you.
Great, congratulations, I appreciate that. A couple of things to ask. So what is one thing your graduate advisor doesn't know about you?
I have 3 hamsters.
We blew that now, so that's great. 3 hamsters.
Yeah.
And then when you were thinking, maybe ask, how long have you had hamsters? How long has that been a part
Oh, it's
of your...
been half a year, and 2 of them are actually related. It's mother and daughter. They live together. The mother loves food. Sorry, I'm sharing too much.
Okay, no, that's great. Tell me about research at UC Santa Barbara. How has that been for you as an experience, and what drew you to UC Santa Barbara?
Yes, so research at UC Santa Barbara is so amazing. For my project, I got to collaborate with professors, postdocs, and grad students from 3 UC campuses across departments. Like, it was such amazing to learn and work with everybody else.
How'd you pick UC Santa Barbara as a place to go?
So before I met my advisor, I was reading his paper, and I was saying, oh, this person's so smart. I want to work with him. And there's beach, there's mountain, there's ocean. So Santa Barbara.
Okay, great. Got all 4. That's great.
Yeah.
And what would you like to do after you graduate? What's your future career plan?
Ideally, I want to be a research scientist in industry.
Okay, fantastic. That's a good thing to do, and that'd be wonderful. And then if you're ever procrastinating, what is your I'm definitely procrastinating activity? What do you do when you're procrastinating?
Oh, I watch YouTube.
Okay. A variety of things to watch on YouTube
yes,
too.
Yes.
That's a good place to do. And then when you were growing up, when you were a child, what did you want to be growing up?
Oh, I wanted to be an artist, and my dad talked me out of it because, yeah, he was assuming that I might starve to death on the streets.
Yeah, but you could do both. No, right? I think being a great artist is a good thing to do. And actually, your question was speaking about music later on is something to do. And I've had people I've met over the years who have a career and an interest, and then as the career moves along, the interest stays there, and then later in life, the interest is still there and
becomes a
on.
new career.
And you can continue doing that. So I'll look forward to your art and your music as life goes on.
Yeah, thank you
Great
so
to
much.
see you here today. Congratulations.
Thank you.
And our 5th contestant today is Angeliz Vargas Casillas from UC Riverside. Angeliz.
Math is all about solving problems. A problem that plagues biology and healthcare is the growth of keloid scars. Keloid scars are wounds that result in a tumor-like overgrowth on the skin surface that continues to grow past the initial wound. Even a tiny injury, like an ear piercing, can develop into a keloid. They're uncomfortable, itchy, and can even be painful as they grow. Due to their size and location on the body, they can be detrimental to self-esteem. Unfortunately, attempting to surgically remove them tends to worsen the scars when they grow back. Since keloid scars only grow in humans, and sampling existing keloids can make things worse, experiments on humans are not feasible. I created a computer-based mathematical model to conduct virtual experiments without further injuring any patients. The type of model I used is called an agent-based model. Basically, it's like playing God. I simulate interactions between different agents by giving them a simple set of rules to follow. The agents in this case are cells and fibers, like collagen. Collagen lives in the skin's dermis layer. Since keloids make way too much of it, that's where I set up my model. Our collaborators from UCI took skin samples from a keloid's edge and noticed a spatial pattern with 3 different cell types. CCL19, or the green cells, they're the leaders. Aspen, or the pink cells, they're the followers. And in blue, we have immune cells. They're like besties with the green cells. They're usually together. Each model starts with an initial wound region in the upper left. I give the cells instructions on how to interact with each other, and as time progresses, we can see how the leaders, the besties, and the followers behave. The goal is to see that pattern expand to the right, which means the keloid is growing. Out of all the cell interactions that I tested, the ones associated with this output most accurately predicted keloid growth as seen by the forward movement of the cells. Now, our collaborators can test my model's predictions and suggest potential treatments to try to eradicate this invasive scar. See what happens when math meets your skin? But wait, it doesn't stop there. We can extend this model to include another layer of skin, blood vessels, and other cell types to help with cuts, burns, wrinkles, maybe even slow aging. Healthier skin sounds like the correct answer to me. But what do you think? You do the math. Thank you.
These, please.
All right, thank you.
Great, thank you. And tell us a little bit about yourself. So what would you say to undergrads or even high school students to get them to consider studying in your field?
Well, that's why I participated in this. I want to make what I do something that's more, that makes other people more aware of it, right? What we can do with math. Because a lot of times I say, oh, I'm a math major, I'm getting my PhD in math, and people are like, ew, I hate math, right? It's like a common response. I mean, you don't tell your doctor, I hate you, doctor. They're trying to help you, right? So that's the goal. I want people to see that with math, you can do so much more, not just, I'm gonna calculate this, thing, right? So there's a lot of different applications, and that's what I would like to let them know, that look into it, right? Talk to people.
Great, great. I appreciate that. And we have a news reporter here. Can you tell us a story in the news recently that fascinated you or captured your attention?
There's a lot of things in the news recently, and I don't think I want to go there, if I'm being honest with you. Yeah, no, that's, why did you ask me that question?
It doesn't say that. I'm just,
I know.
Okay. So, okay, how about a story in the news that bored you recently? No, I won't do that. What accomplishments outside academia would we like to know about you? What things have you accomplished outside academia?
I love crafting. I make clothes, like I crochet and knit and I sew. I didn't make any of this, but I just do that for fun on my spare time. I love my dogs and playing with them. And yeah, I mean, most of my accomplishments are based around my family, and I'm really proud of that. I just got out in August, but I was in the Air Force, in the Air National Guard. So I'm wearing my Women Proudly Serve pin, right? And they're watching too, hi. So yeah, I'm really proud of that as well, and to be a part of something that's so much bigger than just myself.
Great. Well, a lot to be proud of. We appreciate that. And then what are you thinking of doing after graduation? What's your future career?
I also am interested in continuing the route of industry. I would like to continue skin modeling. I think that's really fascinating, and it has a lot of different paths that you can take. So that's kind of where I would like to go, industry.
And how far are you along in your PhD program?
This quarter is my start of my 5th year, so I'm expected winter 26.
Okay, fantastic. Well, congratulations. We really appreciate it.
Thank you so much. Thank you.
I'm going to take a moment for my colleagues, and let me just, I think it's something interesting to say. So an interesting story that I found in the news. Well, no, I can't think of that. We all are watching lots of news lately, and interesting stories are ones that have other people in them, I'll say that. I enjoy that very much. But rather than that, why don't we welcome our next contestant to the stage? And let me say I'd like to welcome Jenna Myers from UC Santa Cruz. Jenna.
Let me let you in on a little secret. We're not getting any younger. And just like us, our blood ages too. Blood production, or hematopoiesis, is a process that begins in the bone marrow. Stem cells in the bone marrow make all kinds of blood cells, like immune cells, red blood cells, and platelets. The key here is the platelets. Platelets are important. They help the blood clot, to stop bleeding when we get injured, but here's the problem. As we age, our stem cells start to make more platelets. More platelets means more clotting, leading to blocked arteries that cause stroke or heart attack. So how exactly are these platelets produced? Stem cells in the bone marrow normally go through a series of steps to determine which type of blood cell is needed. But as we age, a shortcut emerges, prioritizing only platelets. Using this shortcut, aged stem cells can now produce platelets more readily than ever before. And not only that, but these platelets are even stickier than normal. So, dangerous shortcut. I'm sure you're wondering, what causes it? Me too. We often hear that things like diet and lifestyle affect our gene expression. True. But aging itself creates changes as well. By studying the age-related changes that affect our gene expression, I'm tracing this shortcut back to the source. Whether that's a single gene or a group of them, targeting this source will allow us to fine-tune this shortcut like a dial. By turning it down in older people, we can reduce the risk for heart disease, often seen with age. And by turning it up in younger people who don't have enough platelets, we can help them heal faster from injury. So in the end, it all comes down to a sticky situation. The simple act of aging directs the stem cells in our bone marrow to create more sticky platelets, increasing our risk for heart disease. But if we can selectively manipulate that shortcut, we may be able to turn that sticky situation into a good one. Because where blood flows freely, life follows. Thank you.
Jenna, for you, if we can.
Thank you.
Great.
Oh, I forget to take it.
Right.
Everyone forgets to take it.
It's really simple. Okay. But a couple things for you. What made you think of going into stem cell research? How did you get interested in that first?
I mean, similar to what has been said before, I had no idea that this was what I was going to study. When I entered grad school, I thought I was going to study something completely different. But I don't know, I was really inspired by my PI, honestly. I thought she was pretty cool, to say the least, and a really interesting person to learn from. And stem cells are very relevant in this day and age, and they have a long way to go. So I think that's exciting.
Great,
Yeah.
great. Pleased to hear that. And if you are thinking of recent developments in the stem cell research field, what is a particularly exciting area that you've seen? What has excited you recently?
I mean, all kinds of things. Did you know, this is a fun fact.
Okay.
This is a fun fact. Did you know that they're working on making embryos from skin cells? So if you're not able to reproduce, programming skin cells to like sperm or eggs to find another way for like in vitro fertilization or alternative methods, which I think is really cool.
Pretty interesting, and maybe if we had a mathematical model, never mind. I think we're completely useless. I think we're completely unnecessary, which would make things simpler. Let's say you wake up one morning and you're magically the head of the White House Office of Science and Technology Policy.
Uh-oh.
Right. Yeah. Be careful. So what's the first thing you would advise the U.S. to do in regarding science and biotech education for students? You're advising the country on science and biotech education for students, and you get to choose.
They said you weren't going to ask hard questions.
I'll tell you the answer. No, go ahead.
No.
Go ahead.
I mean, I would say if science isn't like a particularly interesting subject to you, you haven't found the right subject matter. And find a subject that you care about, and then figure out what is the latest on that disease or whatever your interest is, and invest in that.
Fantastic.
Yeah.
Okay, and then I heard. I'll try to make this question easier. You
Thank
had
you.
two pet donkeys as
I
a
did.
child. What the hell? No. Tell us about that.
I'm from like a small town in Wisconsin, and yeah, we had a couple horses, and then we decided to get donkeys. I don't really know why, but they were pretty cute. They made a lot of noise, like a lot of noise, so we had to get rid of those.
Okay. Understand. Appreciate it all. Congratulations.
Thank you.
Our next contestant is Sophia Miliotis from UCSF. Sophia.
Five years ago, after the worst breakup of my life, I did what any single millennial does. I got on Tinder. But if there's anything worse than heartbreak, it's getting trapped in an infinite scroll of Bay Area tech bros, living in the cloud, but still down to earth. No matter how long I swiped, the feed never seemed to end. Funny enough, your immune system runs its own sort of dating algorithm, but instead of looking for love, it looks for a virus. Inside infected cells, major histocompatibility complex molecules, or MHCs, are like singles on a dating app. They're constantly swiping through tiny pieces of the virus, called peptides. If there's a match, MHC takes that peptide on a date to the surface of the cell. And there, the immune system can check in, like a skeptical best friend looking for red flags. And viral peptides are full of red flags, so once spotted, the whole cell gets destroyed. At least, that's how it's supposed to work. But some viruses don't play fair. Like HIV, the virus that causes AIDS. It evades immune detection by rapidly mutating, generating millions of unique peptides the immune system has never seen before. And as a result, some infected cells escape and linger in the body for decades. But despite being incredibly diverse, HIV peptides are still on Tinder. They're still matching with MHC. And if we could pinpoint the exact peptides that make it to the infected cell's surface, we'd have a way to track down these lingering cells and destroy them for good. But here's the problem. Right now, we're simply guessing at which peptides might match with MHC and testing them one by one. And with millions of possibilities, we're stuck in that infinite scroll. My research changes that. I'm using a tool called EpiScan, which screens hundreds of thousands of HIV peptides at once.
Here's how it works. I start with millions of engineered cells. Each one carries a single HIV peptide. Inside the cells, if there's a match, MHC heads to the cell surface. And the stronger the match, the more MHC shows up. So I can isolate the cells with the most MHC and check who MHC matched with. And that peptide may be the key to the next HIV therapy. Because finding love is a mess, but finding HIV doesn't have to be. Thank you.
Thank you, Sophia. Again, we'll look it up.
Thank you.
Great. So you came up with a matchmaking app to start your, as a metaphor to explain your research. How did you decide to do that?
Well, I mean, my research is all about this, molecule called MHC, and MHC is constantly like swiping through tiny pieces of virus. It could also be self-proteins, and so it's just like going through tons and tons of different options. And at first I thought, okay, they're matching. Maybe it's like speed dating, but then I thought, I guess dating apps are like speed dating on steroids, and it's a little more relevant maybe. So yeah, that's kind of where that came from.
Fantastic. I appreciate it very much. Was there, we all have our careers and they move forward. Was there a time in your graduate studies when you thought, gee, this is not for me? And what did you do if that happened to keep yourself going?
Yeah, that's a great question. So I did a couple of rotations before I ended up joining my current lab. One of my rotations was very computation heavy, and I didn't come with any computer science background or anything like that, but I wanted to give it a try and see if maybe I could jump into that field. Was not the case. It was really hard for me. But luckily I had more rotations lined up, and yeah, I decided I needed to stay in the wet lab, I guess.
Fantastic. How'd you pick UCSF as a place to train?
Yeah, so I actually worked in industry for a couple of years in the Bay Area. So I was already kind of established here, and a couple of colleagues at the time had gone to UCSF and had gone through my specific program too. So that really helped kind of steer me towards UCSF, and it was always my top choice. So
glad it worked. And then what challenges in your field keep you up at night? What things really worry you?
Oh my gosh, I mean, there's so much that we still don't know about the virus, even though it's been, this field has been studying HIV for such a long time. And it's constantly mutating, like I say. It's constantly like one step ahead of us. But I think that there's a lot of exciting technologies coming out and in the pipeline. And so hopefully someday we can get ahead of the virus.
Fantastic. And you were in industry, now in school. So what's a skill you've picked up in grad school that has nothing to do with your area of study, but that you think will be useful in life?
Ooh. Let's see. I think time management, probably. This is the first time I've had to juggle multiple different projects at once and multiple collaborations, and keep a strict schedule and have meetings, and so it's a lot of stuff going on at once, and I've really had to challenge myself to keep a very organized calendar.
Fantastic. Great to meet you.
Thank you so much.
And our next contestant is Jessica Zhong from UC San Diego. Jessica.
Imagine standing on the shores of California's Central Coast, staring at the vast ocean. Beneath the surface, a great white shark, a powerful and elusive predator, glides silently through the water. But how do we know it's there? How do we detect a species that roams between continents, dives to depths of over 1,000 meters, and doesn't need to surface for air? What if I told you there's a way to detect these animals without ever needing to see or touch them, and it lies in the very water they swim through? My name is Jessica Zhong, and I'm here to tell you about how environmental DNA can be used to monitor white sharks. As apex predators that migrate across all oceans, white sharks provide crucial top-down controls on marine ecosystems. Acoustic tagging, where sharks are implanted with an electronic tag, has given us invaluable data about where they go. But it's an expensive process and, frankly, not something the sharks really appreciate. What about visual surveys? Well, you'd better hope the sharks are feeling photogenic that day. Most white sharks remain untagged and unseen by us. To truly understand and protect these magnificent animals, we need a new tool, one that's cost-effective, time-effective, and non-invasive. This is where environmental DNA, or eDNA, comes in. Every living organism leaves behind tiny traces of genetic material in the form of skin cells, mucus, and feces. Yes, even you. Using cutting-edge laboratory techniques, we can collect and analyze this DNA from seawater samples taken near the surface, confirming white shark presence without ever needing to get up close and personal. In our study based in the Monterey Bay of California, we compared environmental DNA methods with traditional acoustic and visual tracking. I used special DNA filters to analyze dozens of bags of seawater collected over 3 years at a known white shark gathering site near Santa Cruz by my team at Stanford University. The results were astounding. We were able to successfully detect white shark DNA in 85% of our water samples. With eDNA, we can now monitor sharks at a much broader scale using much less effort. Think about what this could mean, not just for sharks, for biological conservation worldwide. A single 2-liter bag of seawater contains nearly infinite potential. It can contain data about entire communities of organisms, or genetic fingerprints from individuals, or even signatures from species thought to be extinct. This could revolutionize the way that we protect endangered species or combat illegal fishing. Let's make sure to embrace this era of using molecular tools to get more data from less material so that we can make sure our oceans stay healthy for generations to come. Thank you. Thank you.
So a question about this. I mean, let's say you're going to go swimming. Can you see if the shark's there now? I mean,
unfortunately, the process, well, it's pretty fast for molecular biology standards. Still takes about an hour or two before you get your results.
Yeah, I'd like to have a little screener to tell me it's a green day for going in the water. No white sharks in here, but that would be a good thing.
Well, it's similar technology to a COVID test. It looks for certain types of DNA that are there. So maybe in the future, it'll be 15 minutes.
Yeah, I think you could probably market that. So that's a good. That would be a good thing. I saw a movie where that would have. Never mind. How did you get interested in oceanography and marine science at the beginning?
I've just always been super curious about the ocean growing up in North Carolina by the coast. And I think the ocean is, one of the last big unexplored frontiers compared to, well, I don't want to rag on anyone else's study system, but.
Go ahead, nobody. No, go ahead.
But every year we have all these rare and unusual creatures wash up in California that we really don't know anything about. So I think there's just so much work to do there.
Fantastic. And what findings in your research have surprised you the most? What did you say? Oh my goodness gracious.
Oh, well, the sharks are always there, whether or not you can see them. That's something that was a little surprising to me. There's a bit of a mismatch, I think, in the public perception of what they're doing, how much they want to eat you, and what they're actually doing, which is just constantly enjoying their home, which is the California shore.
I do have a little so how do I know if one is enjoying the home or wants to eat me? I guess you do that, but you learn that after the.
They're always there.
They're always there. They're always there, and my fear is they're always hungry. But I won't ask that. I won't ask that. But good to know. So they're always there. How close to the shore are they for people?
They tend to stay where the water's a little bit deeper. Again, they do dive to like over 1,000 meters, which we know from our electronic tags.
Yeah, fantastic. And what kind of questions do you typically get about great white sharks when people hear what do people use? Say, gosh, I'm doing great white shark research. What do people say? Oh gosh, what do they ask you?
Oh, they want to know like if I've touched one. Like obviously I've seen them, but it's definitely a no to jump off the shark boat into the water with the sharks. So no, I have not touched one.
Let me say good, good for you. And if you could switch research topics with someone else here, that's a great one. What, no, actually, let me not ask that. I think that's a little, so never mind. Let me say a couple of things. First, exciting work about sharks and very good thinking about not jumping in the water. And I appreciate the idea of marketing a little sign to tell me when it's safe. I think those are all good things. Great to see you.
Thank you very much.
Appreciate it.
Thank you.
And our next contestant is Adekunle Adewole from UC Merced. Kunle?
Who here has taken allergy meds this spring and felt drowsy? Anyone? That happens because medications don't just go where we need them, they are absorbed through our entire body, affecting other parts not intended. That's why chemotherapy often produces side effects like hair loss, nausea, organ damage, because it doesn't just affect cancer cells. Healthy cells are also affected. But the drugs themselves are not the problem. It is how we deliver them that we should look into. This is where drug cages come in. You can think about drug cages like super tiny pouches for medicine designed to open only at the right destination. And so, to make drug cages, we turn to nature to select one of the most abundant items in our body, called peptides. Peptides are essentially your proteins. Now, not just your protein shake, but information carriers in your cell that often dictate how things behave, respond, or even appear to us. Yet so simple and small and can be made with just chemicals in a lab, because essentially they are baby proteins. One interesting thing we actually see in nature is how organs and tissues are formed through baby proteins. Quick example, imagine you zoomed into a hair strand. You're gonna see something like this. Large peptide zippers holding everything together. These zippers are everywhere, including your nails and muscles, that scientists have studied them so well that we can now engineer peptides that zip like this from scratch. And so, great candidates to make this drug cage. However, here is the biggest challenge. Drug cages are three-dimensional, but peptides are not complex enough for that kind of precision. Here's a picture again with my jacket. My jacket was created from a fabric which was created from a thread. But it is a difficult task to make my jacket straight from the thread, so we use the fabric. Previously, peptide scientists have tried to make my jacket straight from the thread, and that didn't go well. This is where I come in. Through my research in the Merced lab at UC Merced, I have advanced this work by designing peptides at the jacket or at the fabric level, closer to the jacket. What I do is use chemistry to weave peptides into triangular tile pieces like here, which are able to zip along the edges to form my predefined drug cage, like my zipped jacket. Basically, a drug cage that can zip and unzip based on demand. And so just imagine if cancer patients never have to worry about hair loss or kidney failure because we can now zip and unzip cancer drugs. So the next time you zip your jacket, I want you to remember that the side effects of your meds are one zipper away from being gone. Thank you.
Please, a photo. Great, thank you. And a couple things we'd love to learn about you. Maybe something unusual that you discovered in your research that you didn't expect, weren't thinking about.
I would say in my journey as a researcher, I think I always try to think about research as where you discover unusual things. And so I think it's kind of like a pattern now where you have all these hypotheses and you're like expecting something, but with an open mind, you know something might go wrong, which is part of the discovery. So I think I'm just used to that already too.
Fantastic, appreciate it. And what's a hobby or interest that you have that people may not know about?
Okay, I think maybe to this room, I actually sing. So I've been in stage plays. I do musicals. I actually had a performance last Friday while preparing for Grad Slam. Okay. And so it's been a big shuffling, so like combining the science or the scientist with the artist. And so some people only get to see one version of that. Just a few people have seen both.
Appreciate that. That's great. I'm thinking we could actually put together a band and have a little graphics art.
I was
design
thinking
and,
about
yeah,
that too. I was thinking about that too.
What would you hope to do after graduation? What do you think you're doing in the next phase?
Okay, I think this has been said many times here, so I'm just going to repeat it again. I think I also would want to go into industry. I think how I think about my kind of sciences or my style in science, I like to be closer to the applications. And so I think industry, I appreciate how we do all this fundamental research and try to understand how the world works. And I kind of want to be part of the people that implement that. And so I would like to pursue industry careers too.
Appreciate that. If you had a chance to meet someone who lived in history or someone who's alive today, who would you like to meet? Present company, I mean, somebody else in the world.
So someone from history?
Or yeah, just someone either history or someone from today, someone you'd like to meet.
That's a hard one. I can't choose.
Okay. Well, you keep thinking.
There's so many. Okay. I can choose.
And then another question that they ask, I like this is, what is your favorite meme that perfectly captures grad school life? You're gonna go back to meeting somebody from history, I think.
I think it's there's a Barbie meme, like from the Barbie movie about Ryan, where he was like saying, my job is just lab, because that's all I do. And most of the times, like people ask me at the start of the semester, what's your schedule like? I'm like, lab, 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 and lab, because that's all I do.
Fantastic, got it. Thank you very much, congratulations. And our last contestant for this morning is Yara Khatib from UC Davis. Yara?
Imagine your brain as a vast city made up of a complex network of roads, bridges, highways, connecting all of the different areas. These different pathways allow for memories and thoughts and emotions to travel seamlessly, kind of like cars navigating through a well-organized traffic system. But now for a moment, let's imagine these roads begin to crumble. Bridges break down, highways shut down. Suddenly, the city's entire communication grid is in chaos. Well, this is what happens in the brain when brain cells and their connections break down, a process that we see in many mental health disorders, like depression, anxiety, and addiction. And when we look at the current treatments available for these conditions, we see that they primarily focus on managing the symptoms, but they're not really addressing this underlying structural breakdown itself. What's more is that these treatments often leave patients with a long list of unwanted side effects and leave key aspects of these conditions unaddressed. So what if, instead of just easing the traffic delays, what if we could actually rebuild the roads? What if we could restore the highways, reinforce the bridges, and restore the brain's structural integrity in a way that fundamentally modifies the very nature of the disease itself? And what if we could do that with just a single drug, at a single dose? Researchers in the Olson lab at the UC Davis Institute for Psychedelics and Neurotherapeutics have found that psychedelic drugs like LSD and DMT can both rapidly and persistently restore these lost connections in the brain. And what's really critical here is that this restorative effect has been linked to the long-lasting improvements to mood and behavior that these drugs have been shown to cause. Now, while these drugs are notorious for some hallucinogenic side effects themselves, our lab has found that you can actually tease apart the restorative qualities from the hallucinations and make new psychedelic-like drugs that only harness these restorative properties. So as the field begins to pivot towards synthesizing and identifying these new psychedelic-like compounds, we need better tools to get us there faster. And that's where my research comes in. As a member of the Olson lab, I'm developing an automated tool to allow us to find the best drugs possible for restoring these lost connections in the brain. Essentially, a tool that'll allow us to find the best materials needed for rebuilding the brain's roads and bridges. Using an advanced imaging technique, I take pictures of thousands of brain cells treated with our potential drug candidates, and then I assess the effect on cellular structure using custom-built software from within our lab. This allows me to pinpoint exactly which drugs are capable of regrowing cells, and in turn make new treatments that don't just address symptoms, but are actually rebuilding the road to recovery. Thank you.
Thank
you.
Great, appreciate your work, and I like the picture of the healthy brain and then the high brain, I guess. I mean, whatever. One on the edge has a lot more color than the one on the right. What did you want to be when you grew up? What was your career path when you were a child?
When I was young, I wanted to be a doctor. I wanted to be a physician. And as I was working my way through that path, I found that I'm more interested in the basic science elements of things, and I kind of wanted to work towards discovering something rather than working on a one-to-one basis with patients in a clinical setting. And so that brought me here.
Great. Yeah. How did you decide UC Davis, and where'd that come from?
I actually was interested in the lab that I'm currently in. I'm very interested in the field of neuroplasticity, which is essentially this restorative quality that I'm referring to that these compounds have. My interest in this research drew me to the lab, and I learned more about what they were doing and utilizing these psychedelic compounds as tools to study this phenomenon that I'm interested in. And so I reached out to my PI and I said, I'm interested in coming to the university specifically for your lab. Do you have funding? He said, try your luck. And I did, and here we are.
Okay, very well. Worked very, very nicely.
Luckily.
Yeah. And then what's your best memory of grad school so far? What thing stands out? So that was terrific.
So in my early years, my lab mate, who she's here today, we worked on these long 10-week experiments with animals where we would go in every day and weigh bottles to look at their consumption of different liquids and compare that over time and in response to drugs. And that required for us to go in at maybe sometimes 2 in the morning so that we can assess during their wake hours, because mice are active during the nighttime. So we set up a mattress in the lab and we spent the night there, and we would get up periodically every 4 hours and go weigh the bottles. And at the time it was just so tiring and tedious, of course, but I look back on it now and it's some of my best memories in grad school.
I have to think about that a little bit, but okay, great. We'll accept that. I appreciate it. And what would you, if you won the Grad Slam, what would you do with your winnings?
Definitely pay off things that need to be paid off. And probably set aside travel money for conferences. I did not think that would be such a big hurdle in grad school. Is like the ability to go to conferences, you need money for it. And if you're not winning awards, then this is kind of the way that I could potentially fund those kind of things. Yeah.
Fantastic. Wonderful to meet you. Thank you.
Thank you so much. Thank you.
So maybe time to take a breath and give a round of applause to all our presenters today. Really great work. And I think now I'd like to turn over the reins to our Associate Vice President for State Government Relations, Kathleen Fullerton. Yes, hi, Kathleen, great. And how about a round of applause for Kathleen, too, as she ascends the stage.
I've been instructed to stand as far to this side as I can. Hi, everybody. I'm Kathleen Fullerton. I'm the Associate Vice President and Director of the State Government Relations Team at the Office of the President in Sacramento. It's a mouthful. What that really means is that my team is the primary interface between state government and the University of California. So we get to interact on a daily basis with legislators. I see former Senator Bill Dodd over here, worked with you a lot, and our partners in the administration, the governor's office as well. This partnership has led to extraordinary collaborations between the university and state government. When we meet with members and members of the administration, we say, how can we connect you with UC resources, with UC researchers? What expertise do you need? How can we help the state of California move forward? And some of the really important and interesting collaborations we've done most recently include UC Riverside, working with the California Air Resources Board on a interesting device that helped detect some major automakers cheating smog tests in California. So if you remember that came out of UC Riverside. UC Berkeley works with the system-wide database to provide the public with free access to really important demographic information, electoral information, census data. This really leads to a more informed public. That's all for free. UC Davis, UCLA, they've teamed up with Cal OES to work on cancer-related work to study biomarkers in firefighters. Really important work that's prevalent today. I especially want to mention the Climate Action Grants from 2022. This was a great partnership with the state, over $100 million approved for 130 partners for community-based climate resilience projects. So that included collaborations by us, CSU, community groups, tribal entities, really just a cohesive group of communities and researchers coming together for the benefit of Californians. So I just want to put in a quick little plug here. This collaboration is essential to higher education, to research, to health, to the state of California. It does require resources, especially ongoing considerations of federal and state budgets and what that's going to look like. So just wanted to say congratulations to all of you and keep up the good fight for higher education and research in the state. It's leading to really wonderful and amazing outcomes. Yes. Okay, so the part that I cannot mess up, I'm going to read it. I want you now to vote for the People's Choice Award. All of you will have an opportunity to vote via text. In fact, please take a minute to do that now, as voting will be open for only 5 minutes. The screen behind me has information on what to do. And those of you watching our live stream should see that information on your screen. Or you can go to our website, gradslam.universityofcalifornia.edu, and find the instructions to vote there. The top vote getter will be awarded a $2,000 People's Choice Award. To vote, please send a text to 1-239-667-0268 with the corresponding letter A through J for the names listed on the screen behind me. A couple notes: you can vote only one time. Once you've submitted your vote, you cannot vote again or change your vote. You can only vote by texting your vote from a cell phone number. International mobile numbers must have an international data plan that allows sending SMS text messages to a US number. And stay tuned to the event for the results. So, the phone number, yes, 1-239-667-0268. All right, so we have now opened the voting. It will be kept open for about 5 minutes, so don't delay. Please vote now. And now I'm going to turn over the program to my UCOP colleague, Vice President of Graduate and Undergraduate Equity Affairs and Vice Provost for Equity, Diversity, and Inclusion, Yvette Goulat.
Can you hear me? Are you able to hear me?
Nuh-uh.
All right, is that better? Great. Well, thank you, Kathleen, and wow. I would not want to be one of the judges right now. So I am very happy that I have a chance just to moderate this really distinguished panel. And let me introduce them to you. You have their bios in your package, but trust me, that does nothing to explain the extraordinary people we have for you today to talk about the future of innovation in California. So I'm going to start right here with Jillian Wilson. Jillian is the Vice Chancellor for Research, Innovation, and Economic Development at UC Merced. Her administrative portfolio includes managing UC Merced's research administration offices, shared core research facilities, organized research units, the Natural Reserve System, the Agricultural Experiment Station, and the Central California Small Business Development Center Network. She is a professor in the UC Merced Department of Physics and a fellow of the American Association for the Advancement of Science, the AAAS, the American Physical Society, APS, and the American Astronomical Society, AAS. Welcome to Vice Chancellor Wilson. Next to her, we have Lisa Garcia-Bedoya, who is UC Berkeley's Vice Provost for Graduate Studies and Hitchcock Dean of the Graduate Division. She's also Chancellor's Professor in the School of Education. She uses the tools of social science to reveal the causes of educational and political inequalities in the United States, considering differences across the lines of ethno-race, gender, class, geography, and more. And finally, we have former California State Senator Bill Dodd, who is a fifth-generation Californian and was a successful business owner before being elected to the Napa County Board of Supervisors, the State Assembly, and the State Senate. He is a partner in Dodd and Chiban Strategies and serves as a director of a public company and 2 startups. Please welcome our distinguished panel. All right, so let's begin. So we've just been listening to our students take complex ideas, processes, and sometimes mountains of data, millions of peptides apparently, to convey their meaning and their value in accessible ways, all in 3 minutes or less. So since you are all already so accomplished, so experienced, we thought we would make this a little interesting for our group today. In the spirit of Grad Slam's communication of ideas and information, in limited time, I'd like you each to respond to the following prompt, and you've got 2 minutes.
But what are you going to do to us?
Just you wait, Dr. Bodoya. UC sets the pace for innovation nationally and drives California's economy. Given the current political landscape and various federal actions, which are profoundly impacting research in higher education. In 2 minutes or less, please share what you consider to be the 2 most important things that must be accomplished in order to keep California a world leader on behalf of innovation. And no worries, the judges are off duty. You will not be judged. But please share your thoughts, and who would like to begin? What do we need to do?
I can go first, if you like.
Yes.
First of all, I'll take my 2 minutes to test if my microphone is on. Can people hear me? And then I'll turn to the grad students and say again, wow, that was incredible. The best of University of California was heard today. So congratulations on describing your work so informatively in 3 minutes or less. They just want to know who's won. They're just looking at me. Now they have to sit through this panel. I'm sorry, we had to come. Anyway, back to the question. It's such a timely question. If we want California to stay at the forefront of innovation, I think 2 things are absolutely essential. The first of this is we have to keep investing in research and education. Innovation doesn't happen by accident. It's the result of decades of public support for research universities, for national labs, and for community partnerships. With everything that's happening at the federal level, California needs to lead by example and continue to fund the ideas and the people that drive discovery and entrepreneurship. And second, in my opinion, we have to make sure that innovation is for everyone. California's diversity has always been its superpower. If we open more doors, especially for students from first generation and underserved communities, and maybe even, in my case, newly minted PhDs, folks who have a new PhD in physics and would like to pursue opportunities in an amazing state that aren't available to them in their home country. We're not just doing the right thing morally by expanding opportunity. We're expanding our talent pool, fueling new ideas, strengthening our economy. In my opinion, innovation thrives when we tap into the full potential of all Californians. So in short, stable investment and inclusive opportunity are the foundation of California's innovation.
Thank you. Innovation for everyone. Who would like to go next?
I'm happy to. I'd also like to just say to all of the students, y'all are amazing. I mean, just absolutely amazing, and it's almost embarrassing to be coming after you, but I'm going to do my best. So Julie and I agree on many things. I would say the 2 most important things that we need to continue to do in California to remain a world leader in innovation is to stay true to our values in terms of vigorously defending our academic freedom, which I would define as the freedom to speak, the freedom to learn, and the freedom to discover, and also reinforcing our commitment to ensuring equity of opportunity for the people of California. In a New York Times piece that was published yesterday, venture capitalist David Singer wrote that, quote, transformative innovation often begins with a new understanding of the world at its most basic level. And this understanding almost always emerges from challenging accepted wisdom. That requires a space for free inquiry and a culture that protects it.
You cannot do science in a world where there are acceptable questions and unacceptable questions. To compromise on that fundamental intellectual freedom would destroy what has made the University of California, and I would argue by extension the state of California, drivers in innovation for more than 150 years. Right now, California's economy is the 4th largest in the world. We just surpassed Japan in terms of economic outputs. It's just something to really think about, right? We are a state. Many countries and many other US states surpass us in terms of natural resources, population size. What makes us different? I would argue that a key aspect of California's secret sauce is the investments it has made for the last 70 to 80 years in public higher education. We invested in our people and created a public higher education infrastructure that is second to none. The California Master Plan codified the idea that, quote, some form of higher education ought to be available to all, regardless of their economic means, and that academic progress should be limited only by individual proficiency. That was a pretty radical thing to say in 1960, right? I think we need to really lean into that and remember that. And even though we've never fully realized that goal in the university, it is one I think is worth fighting for and which underpins California's innovation. California also was the American frontier. The frontier is a place where boundaries are crossed, where society's rules don't necessarily apply, and where people can dream big. It is not by accident that so many from so many parts of the world have been drawn to the frontiers of California's energy, its natural beauty, and its expansive universe of possibilities. We need to remember that those with the guts and the grit to brave that frontier are the exception to the rule. Most people want to stay with what's familiar. The energy, new ideas, and out-of-the-box thinking that those newcomers brought, combined with their hope and determination, have made California what it is today. So California needs to continue to embrace that energy and those new ideas. We need to recommit to and reinvest in public higher education, working to ensure that it is accessible to all, regardless of their family background. Imagine what would be possible if we embraced our freedom to question the status quo and value diversity across all dimensions. If we do those two things, the sky's the limit in terms of what we can accomplish. Thank you.
Thank you. Keep improving that secret sauce. That makes us wonderful. Yeah. Before we move on to Senator Dodd, I would like to introduce our final panelist, Samuel Assefa, who directs the California Governor's Office of Land Use and Climate Innovation. And prior to that, he held key positions in the cities of Seattle, Boulder, Chicago, and San Francisco. Please welcome Mr. Assefa to our panel. You've got 2 minutes.
Got 2 minutes, okay. First of all, I want to join my colleagues up here and just thanking you for the amazing presentations. I think there is something somewhere about the field that you're in. It's so amazing when you're able to articulate the way you are all able to articulate each of your own presentations. To the average person, or maybe to most people, it's boring, but when you listen, and you listen to how you did that, each and every one of you crafted your own way to be able to help us. I was looking around the room, smile, and really, have a much better experience. So congratulations to all of you. The two things for me, I agree with the investment. When you stop and think about the challenges that we have today in so many areas, I was just thinking during my tenure as a legislator over 10 years, fire science, equine, we have horse racing problems and horses getting injured. The study that went on at UC Davis was absolutely essential to trying to solve those problems. Cancer research, air resources, smoke taint for our wines. I'm from Napa Valley, so that is a great interest to me. We got to make sure that we always have the finest. And of course, I said climate change. That's first and foremost on our minds. And without the investment that we've had, even from the US government, we would not be able to do a lot of that. So for me, continuing that investment unabated with politics, it cannot happen. It does. We're seeing it in real time, and I think it's disgraceful. The second thing would be a no intervention by government policy. Now, how realistic really is that? But I would say that would go not only for the President of the United States and the cabinets. I mean, look, there's got to be some there's got to be some mechanisms to make sure that it's done fairly and it's done to the highest scientific techniques, so the investments go to the best places. But then also, it should even extend to legislatures, including the state of California. And when you've got empirical evidence that the state of California has really, in many respects, disinvested in the UC system over time and systematically into research, as well, using the legislature to try to solve some of the problems or perceived problems, challenges that the UC system has, which is frankly, I'm getting into politics of a different source, but I fought these politics while I was in the legislature, and I believe them in my heart and soul that our legislature needs to take a hands-off approach to our great UC system. They have a board of regents that governs them very, very well, and I think there may be some circumstances under which we could collaborate, but putting the pressure on the UC system to do things as government sees fit is not necessarily the best for the system.
Right, thank you. Unshackle research. Thank you. And finally, Samuel, what would you add to this discussion?
Well, I agree both Senator Dodd and previous speakers in terms of research, especially. I think there's no question the UC system is one of the best in the world for that. And my office engages with UC in all land use related transportation, equity, environment, in all of that. And we have to take advantage of that. But let me put some kind of meat to the bone of why that is important. 2006, I was in China for the first time. I was working in Chicago at the time for Mayor Daley, who saw from before anybody else that China is going to be dominant in 20 years. So he wanted to open an office in China. Out of many events that the Chinese hosts took us around, one of them was at an abacus museum in a city called Nantong, China. And in the Abacus Museum, those of you who don't know the abacus, you should look it up. And 2,000-year-old, I forgot the date. And the museum had the first abacus to the subsequent improvements all the way to the latest computer. So the message they were telling us was that we invented the computer and it got better. So we're sitting in a big hall. They were like leaders, actually. This one was for a different forum in China, a different trip, but the same year. 20 mayors from around the world. So the stage like this, they had 12, 13, 14-year-old kids standing in front of a long pad was full of numbers, 500,000, 600, whatever, divided by square root of, plus, all the way down. Each row had a missing number. And the MC would ask the audience, fill in the number. They do. And a guy sitting on a computer, and a guy would say, go to the kids. They turn around, and they write the number. And then they show it to us. And the guy on the computer is calculating all these complex numbers. Each time, they get it. This was 2006. That evening, I was sitting at the banquet next to the top recruiter for IBM. And he said to me at that time, he goes, for the top research and or development or programming for IBM when they hire, they get about 3 or 4 at most finalists who would qualify for that position. He said in Shanghai, he gets anywhere from 600 to 1,200. I mean, this is not an exaggeration, that they can qualify. This was 2006. So research and investing in students is a critical part of it, and not just the research itself. So investing in people. You know where China is today. And they're not dominant because work and products are cheap. They're dominant because they have the best education system and the best investment in their students. So same thing goes to California. And the second part is really about embedding resilience, if we're talking about climate, into our innovation. And that's part of what my office is doing. Now, as we look at land use, climate programs, all interrelated aspects of what makes what impacts our climate change and the decisions we make on the ground, research and innovation around the technology is so critical for that. We are conducting the FIBS climate assessment, which we do every 5 years. So innovation in AI, innovation in GIS systems, mapping are so critical in helping us inform our decisions around those issues. So those are the two things that I think are critical.
Okay, thank you. And you've touched upon something that, and we've been dancing around it all morning, so let's just really get into it. We are seeing dramatic, actual, and anticipated funding reductions from federal sources, on top of what were already limited levels of state support for graduate research education. So given the threats to funding for basic research, which we all understand is the boundary, it's a foundation of cool, boundary pushing, innovation, keeping us competitive research and outcomes, should we be doing more to encourage and incentivize industry to contribute and own more of the expense for basic research, from which they benefit greatly, and to which many of them will benefit from our researchers, as we've heard today?
I mean, I think it's clear that we need to diversify our source of funding for our research portfolio very similarly to how you would diversify an investment portfolio. We are depending on the federal government, largely because the state government backed away from funding UC, and we thought it was a consistent and reliable source of resources. It's also an ethically less fraught source of resources. So I want to name that, yes, we need to diversify, but we have to do so in a way that aligns with our values, and we have to make sure that we have very strong ethical guardrails in place so that industry-funded programs don't lead to outcomes or people putting the thumb on the scale and not doing basic research the way we need to do basic research. So I think there's a lot of work that has to happen in order to make that those kinds of partnerships fruitful. But I think about the fact that, you know, a doctoral student at Berkeley costs us roughly $400,000, $500,000, and then Google goes and hires them. And they benefit from that investment, right? And they don't necessarily see it as their obligation to reinvest in the infrastructure that created that human capital for them to benefit from. So absolutely, I think we need to explore this, but I think just to be mindful that we also have to then have policies and practices in place to make sure that our values, that we stay true to our values, and that we don't cross those potential kind of ethical lines.
Senator Dodd.
100%.
And as you respond, I want you to also think about, as well as Mr. Asefa, what should the state be doing to help us more? Sorry.
No, you don't have to be sorry at all. First of all, I totally agree with everything you've said there, and it's not going to be the hammer approach more than likely, but I think discussions need to start taking place within industry, and we have so many segments of industry, and perhaps there just needs to be more collaboration right away. With those industries, with the institutions that support them, and just in so many areas, biotech and computer science. I mean, it just goes on and on and on, particularly here in the state of California, and certainly, across the country. So I totally agree. Now, the state of California, when you looked at, I know that the governor and AG Bonta are putting $50 million in to supplant the legal budget so that we can challenge some of these things that are happening. And I really think that, maybe it should be more, maybe we should be putting the state, and maybe we are, and somebody was asked a question about what media thing they've seen lately, and maybe I missed, something in this day and age. I'm sure as fast as it is, I missed it, but I don't know if we're going after those decisions. I know that the universities certainly are going after those institutions, but we should certainly be supporting them and helping them with the, with the legal cost to challenge these decisions that certainly, at the least, in my view, are unconstitutional.
Thank you. Anyone else want to weigh in? Please, Dr. Wilson.
I'll weigh in. I'd like to start by saying that innovation goes beyond only graduate students. We need to think about research in general, fundamental research. That's supporting the faculty members who work very closely with the graduate students. It's supporting the labs, the shared core research facilities, as well as the faculty members' individual labs. So there are many components to supporting innovation and growing innovation. My colleague talked about growing revenue streams, and again, I think the analogy of your retirement portfolio is very important. We should be acknowledging this as a moment for a different business model for research within the University of California. And I'm agnostic as to how research is funded, but I would like to see research continue to be funded. So looking at all of the possibilities, where there's federal funding, where there's state funding, where there's philanthropy, where there's investments, partnerships with industry, partnerships with national labs. We got to think creatively, we got to be innovative to keep producing the results that the University of California is famous for.
Last word, Dr. Seth.
I'll add, industry is really critical partner, whether it's, because there's cuts in federal funding so that they can fill that gap. I think that's important in the short term, because this is probably a blip for a while. But I think a lasting engagement with industry is critical in helping fund the programs, because they are the beneficiaries. Of course, you have to put the guardrails. That is really important. And then the state's role, it's not just sticks, but carrots as well. And we've done pretty well for the most part in California, really engaging private sector to be partners. And some of the things that we can do, obviously, we help facilitate and engage private, public, nonprofits, universities to come to the table. But also from an industry's perspective, we have to really cut a lot of the red tape that they are frustrated about. Those are the carrots, especially if you're trying to innovate in new technologies around solar or wind or energy production. They're interested in innovation, but the state should help cut a lot of our permitting and CEQA, which my office administers, and we're doing a lot of that work. So there's a lot of role for the state in terms of from the carrots perspective to engage industry in this. Elon, as my boss often says, Elon Musk would not have been where he is but for states' engagement. Right?
So I want to pull that thread with you just a little, not to unzip or make a whole new jacket, just pull this thread a little bit and ask you and Senator Dodd to be critical friends of the university. What is it we're not doing to facilitate that kind of engagement?
Go ahead. I don't think there's a barrier to facilitate that engagement. I think universities and faculties are, their hands are tied as well. I think universities are more bureaucratic than states. I'm working currently with the UC system and the researchers around climate resiliency, and we're partnering with the Pontifical Academy of Sciences. They're bringing the sciences around climate resiliency. It is amazing to see the amount of resources that they have, and they're willing to come to the table and engaging. I think one area I think we need to focus on is the urgency around climate, that we have to focus a lot more in implementation. So practical aspect of it has to be elevated, not just the academic aspect of it. How we do that, I think we can discuss, but you need to get things, on the ground and not just the research.
I think when I first got in the legislature, I saw that there was really a lack of key personnel that was really working with the legislature, and a lack of communication in many respects. So the legislature kind of, and even for a while after the UC system started bolstering up, the legislature just had their way, with the UC system, with the leverage, because it was all about money. But with a lot of us, that money means higher, if we don't give it, that means higher tuition for students. And somehow that was lost, on the legislature at large. But I'm not saying this because President Drake's in the room or any of the ledge team, but I have really noticed a much bigger, better professional presence in Sacramento. And you know what? I'm sure they would rather not spend the money on, you know, on that and put the money further into other types of things. But I think the analysis, if you really went and pushed a pencil, would show that the cost of doing that I mean, the losses, if you don't do it, far exceed whatever it costs you on the other end. And so it's, I think it's been a great investment, but it's, you know, sadly, you just have to do it. And I just want to, and frankly, you can go back. I'm not going to do it right now, but you can go back and look at the successes that we've had against some mighty, large challenges from the legislature trying. I mean, you look at the president of the United States doing what he's doing right now. In a way, it's not a lot different. It's a different topic, and it's a different intervention, but you see that intervention come in from the legislature trying to get the UC system to do what they want. That's not right. And so I just applaud the UC system for stepping up and standing up to make sure that you're well represented in the legislature, because it has to happen. Sorry, I went longer than 2 minutes.
That's okay.
I saw her looking at me.
Well, I appreciate this conversation. I also appreciate the concrete recommendations that you've all made. I'd like to take a moment now and share the mic with our campus Grad Slam champions, all of whom are the epitome of everything we've talked about. They are the future of research. They have the intellect, the creativity, as we saw today. So I'd like to invite them to join the conversation, and wanted to ask, do you have any questions for our panel? Yes, Dr. Ma.
Hi, I'm Jessica Zhong from UC San Diego. I was wondering, first of all, thank you for your insightful remarks. And I was wondering if you had any thoughts about how you see research priorities at the UCs changing over the next 5 years.
I guess my worry about that is that up until now, there's been an interaction in terms of setting research priorities between PI interests, right, and where people think the edges, the cutting edges of science are, and agency frameworks, right? So there's always been a need to align your research to some extent to whatever is fundable. I worry that there are whole areas of research now, though, vaccines specifically, but others that are really important to humanity that just won't be available for funding regardless of faculty interest. And so my worry is we're going to have a narrowing of the kinds of research that can happen on campus without investments from other sectors that in the long run hurts science, right? Because it means there are avenues of exploration that simply won't be available to researchers in a way that hasn't happened in the past. So I think that's the thing we should all be concerned about and trying to keep from happening.
Dr. Wilson.
So there's an arc between fundamental research and innovation and economic development. And at the very beginning, when our faculty and grad students and postdocs are carrying out fundamental research, it's not clear what the real-world applications of that research might be. One example in physics is Maxwell's equations. Maxwell's equations, who knew that Maxwell's equations were going to result in electric light and power grids and Wi-Fi and all of the wonderful things we enjoy when the grid is up these days? My concern is that these activities, these fundamental research activities, may not be able to get funded because there's no immediate application. So the question arises, well, what's the use of that fundamental research? And the answer is we don't know. Another example is quantum mechanics. We don't know when we're doing the research what the applications will be. And so unless there's a pool of resources to allow highly qualified faculty who've gone through, got their PhDs, been recognized as amongst the best in the world, to pursue their scientific curiosity and make whatever discoveries and creative activities that they are interested in doing, we're going to get stymied at the very beginning. And we lose that later potential by trying to justify exactly what we're doing in our research labs, which is often we don't know what we're doing, that's why it's called research. We're pursuing our interests, and more often than not, something incredibly powerful pops out. But you have to sort of potter, that's research.
I'm going to turn to the audience because I know you all Googled Maxwell's equations. And they are, oh, come on. Okay. Thank you. Any other responses to the question, the arc of research over the next 5 years? I see a hand from one of our Grad Slam champions. Go up, please.
Hi, Adekunle Adewole, UC Merced, chemistry program. Thank you for the wonderful remarks you made. It's been a great opportunity to present with these amazing people here. I just wanted to continue that conversation on how to better communicate the research we do, like especially fundamental research, and having this stymied situation. It seems like this is the situation. So what other ways can we approach communicating these amazing research interests we have and showing or demonstrating how vital it is for the society to progress through that? So what other ways or ideas from your different perspectives can you offer to do that? Thank you.
I'll just offer one, because look, if this is the research, university research system is an industry. Would you agree with that? It's an industry, and a very important industry in our country, in our world. So it's important really not to have the UC system take this on by themselves, or university in New York University or Harvard or Yale or anybody else do it on their own, because it looks so self-serving. And I don't know if there is a trade association of research universities or something, but something tells me that they need some funding right now to get some messaging, clear messaging out to negate this narrative about what's going on at research universities, which is totally and completely false.
Thank you. Other thoughts?
Yeah, I think part of what we suffer from as experts, including myself, we're not very good at communicating, especially the more we know. And we just talk in our bubble. So two things are, I think, critical. One is you really have to make it relevant in the way you speak, talk about the research, relevant to how that is going to impact people, whether it's an individual or society or a city or whatever. You just have to use plain language so that people understand and connect the dots from this research. I mean, some of the complex ones aside that you may not see the practical application, but you should be able to explain it to an 80-year-old or an 80-year-old, not just have discussions along academia, which, you know, people get lost and lose you, because some of them are taxpayers who are going to fund when the legislature proposes one thing or another around research. So I think that's important. The second one is just more about the real world relevance of that research, and be really cognizant of that. I think to the previous conversation, what are we ready for in terms of the research? I think we need to look around. You know, what are the biggest challenges that we have? As a student of cities, you know, over the years, one thing I know is throughout history of development, the most transformative changes in innovation have come because of major, major disasters. 1666 fire of London transformed London from urban planning, architecture, technology. The Chicago fire changed the Chicago completely. The elevator, the steel, fire protection, tall buildings, all of those. So this is that time. You know, COVID was one of them, and now climate change is a critical opportunity. So what are we ready for? I mean, really innovate around those issues that are going to solve the biggest problems, and at least prioritize those. And that's also an opportunity for students that are coming into the space now to be actually excited about it, as daunting as and existential in some cases climate change is. It's also an amazing opportunity that comes once in a lifetime to have that transformative, you know, innovation, research, and work. So it has to be relevant to the time, it has to be relevant to the individuals that are going to be impacted, and we need to be able to speak people language to actually communicate that.
Can I do just, please? You guys just showed us how to do that. I just want to name that what you guys just did is exactly what you're talking about, and I want to give a shout out to a few efforts. Santa Barbara, I think, did it first. They have research in 60 seconds. UCLA now has on their homepage, just talking about impact across people's lives, research, all kinds of things. Berkeley's doing a 101 of whatever thing in 101 seconds, so which seems to be doing pretty well. And Harvard just redid their website. I mean, they have more money than God, but still, they're a good example of, I do think the Academy needs to do a better job of continually making ourselves more legible to the public on all the ways in which we're having a positive impact on people's lives.
Dr. Wilson.
I would say support your local journalist. It's on us to try to explain the work that we do to the best of our ability, but it's also on us to support the media. And journalism is under threat. I have a daughter who is majoring as a journalist this year, and that's a shrinking field. So without anyone to tell our stories and propagate our stories, we're going to be in more troubled times also. So there's all sorts of aspects of the network of communication that would behoove us to think about and to support.
Thank you. Yes, take another question from our Grad Slam champions, Mr. Alvarez. We have time for one more after that, I think.
Okay, testing. Okay, great. You guys had great ideas for moving UC as for higher innovation and really linking UC with, the industries and things like that for better funding and whatnot. But all this is kind of like, I have to trust in these large entities to make these interactions. So I kind of have a two-parter question. The first one is, what is something that I can do now to kind of facilitate these interactions so that we can get more funding? And second, what is kind of something I can do in the future as like a career path that might be able to facilitate and be one of those people that facilitates those big entity interactions?
I see everyone thinking. I know their ideas.
I can take a quick, on the first part, I think just informing yourself where the levers are and who you need to contact, whether it's individuals or organizations. And what I know in engaging with city council and boards, the people who appear at the city council hearing are more likely to get their pet project or whatever accepted versus people just sitting and writing, right? So being present at the right moments at the right places, informing yourself. Second part of your question, for the long term, I think what has worked for me in career since I was, high school is I at least thought about where do I want to be 5 years from now and what are the incremental stuff that I need to do now. And I think the short-term goal of connecting with people and advocating is part of those stepping stones. So really knowing and what you need to do now to be where you want to be 5 years from now. And connections are really important. Knowing people, knowing the levers of either power or decisions or ideas are really important.
If I can add two concrete things. So first, you can join the UC Advocacy Network. You can, in order to assist, and Meredith isn't here, but I'm going to plug all of the state government folks that are doing work. And then the second thing, the University of California has hundreds of thousands of living alumni. If every one of those alumni gave $100 to their campus, that's free money, that's green money, right? That's paying it forward. UC was $1,200 a year when I was an undergraduate at Cal, right? I give money to Berkeley because they gave me an incredible opportunity and I helped to fund the next generation. So I would say, give to your campus, give to the students that come after you so that they can have the opportunities that you've had. And those are two concrete things to do.
Thank you. Anyone else? Great. Let's take one more question. You have it. Oh, okay.
Okay, just to follow up to my previous question, what do you do if you're in like Maxwell's situation where you're actually doing research that is not in your time? It's not relevant to what your environment is at that point. So like those equations came like years before we had these kind of developments, but they were very pivotal to what we're experiencing right now. So then how do you bring even that kind of research to a very general audience, or what kind of ways can you navigate that?
I'm really gonna have to look those up.
Who wants to take that one?
Sorry. Somebody else answer.
You brought him up.
I know.
Yeah.
I'm a social scientist. That's above my pay grade.
I know, right?
Yeah. And I'm a graduate of Chico State University. So, I mean, you're certainly not going to get my answer on that one.
Everything
Nothing
old
against
is new
Chico
again,
State.
Yeah.
Good.
Richard Feynman wrote a famous book, and I love the title, The Joy of Finding Things Out, right? It's just joy of making discovery, whether it's practical or not. That human curiosity resulting in discovery. You can explain, especially any one of the 10 of you who did an amazing job today, what you're working on to a general audience. You can make anything interesting.
Very good. Very good. And one last one from our champions. I know you have it. I can see it. Go ahead.
Knowing when not to ask a question.
Exactly. In the front.
That's smart.
Hi, I'm Angeliz from UC Riverside. And I noticed that this particular group of students here were all very diverse. And I guess one thing that's under threat right now is diversity in the UCs, since we're talking about UCs specifically. So what are some ways that we can address that to make sure that we can keep diversity in our research and in our institutions to keep going with this innovation? Thank you.
I know I've talked a lot, but this is very close to my heart. So I'll start by saying we cannot address the big problems that humanity faces without leveraging the full scope of our abilities, right? Everybody's, right? You need to have people in the room who ask different kinds of questions, who see the world differently across all dimensions. And I think, again, that's what makes UC great. And I do have to say, I think about this a lot as I walk across campus. This has been a tough time, so that's what I do to sort of breathe. The revolution already happened. Like, the revolution already happened, right? Like, the diversity is already there. The question is, are we going to be able to actually provide the services that students need so that they don't have a difficult time while they are moving through our campuses, right? And so I think that's a really critical point. Like, this is really about serving all the different kinds of students who have all different kinds of needs and our ability to do that. And I just feel like naming, because I feel like it's lost. We've been doing this under Proposition 209. We've been doing this without necessarily, judging things by race or gender, but thinking about, right, the full set of human needs that students bring depending upon their backgrounds, and that they're going to be different depending on where they came from. And so managing human precarity and our shared humanity, I think, has to be what we continue to do. And I don't think we should shy away from it or be embarrassed about the fact that that's what we're committed to.
Other thoughts?
I can't speak for UC, but at least from the state, we are actually doubling down in our values around those issues because we are better off because of it, not in spite of it. So it's not about, the political whims now. Yes, it is a challenging time and it has real impact, whether it's financial or political. You don't have to tout diversity on all that, but just be committed in your values and your implementation, our programs, research that you're doing. So at least we are doubling down on that to make sure that we don't, go backwards from that perspective. We may not talk about it the same way, just because of the times, but it is because of that California is where it is, and it is not uniquely, but significantly a California value. And that it goes across party lines. Some of the most incredible legislation passed around diversity and or climate and all these issues that are politically negative now have been done both by Republican and Democratic governors in California. So I think California values will prevail and continue, and I don't see that really backing off. Yes, there will be challenges and bumps in the short term. So you have to look at the big picture.
Senator Dodd.
Got to be. I guess the way I feel about it is, I think each and every one of you, we've got a very diverse group here. You have given to us in California a beacon of light of why DEI is important. We've heard about it here on our panel. I'm incredibly impressed by each and every one of you, and do not believe for 1 minute that if you brought in another subset of people, I mean, I just think what we're dealing with right now that is creating this problem, this challenge, but it's really not a challenge because I see it in each and every one of you. We've just got to overcome ignorance. And that is what we're dealing with in this country, is an extreme plague that has been beneath the surface for the most part for some time, but has evolved in this landslide, if you will, of narrative that's just so far from the truth. And I just think we need to continue to stay the course. And I, for one, I'm so glad, I don't know if we're even done yet or not, but I am so glad that I came, because each and every one of you had a way to explain your own topics, in a manner that I kind of got and appreciated, and then have confidence in our future that this is going to be okay. We will overcome the ignorance that we've got in our society.
That's good.
Dr. Wilson.
Yes. Another word. In my opinion, education is the key. It always has been. And if there are students that are not reached in some communities that are not reached, shame on us. Shame on us and our society for not doing our absolute best to include, back to inclusivity, every student we can. Because there are pockets in the state where there's untapped potential yet to be reached. So it's on all of us to make the effort to engage kids from a very young age and give them that pathway into whatever career would fulfill their potential.
And that's true not only for government and universities, for private sector as well, because it is an economic imperative. Actually, they thrive because of that as well. So there's an economic imperative in that as well.
One of you said diversity is our superpower. I think, yes, Dr. Wilson, and I think that really does embody the university, the state, and what is propelling us to be the kind of California valued fourth in the world economy that we have. Well, let me then, look, it's hard times right now, right? We're all feeling it. We're all belt tightening and doing all the things. And typically I would ask you, so what keeps you up at night? But I am not going to ask you that question. I'm going to instead ask you, what gets you up in the morning? What's exciting? What's propelling you? What's bringing you joy in your work as we move forward in these times? So what's getting you excited to start your day? Morning, mid-morning, whenever that starts. What's getting you up? I think you're going to say climate.
Well, yes and no. I mean, climate in the sense that, again, in my profession, always the challenges are the most exciting things. When your challenge is when the juices flow and you're excited to actually find the solutions, even the political context now. I mean, we're constantly talking about, okay, how do we counter that? It's an opportunity for that, and how, so that's part of it. The second, I mean, this is kind of weird, but true. I have some of the youngest staff in the office. My office historically has been like that, and most people come there primarily, unlike most other state agencies, because there's always creative ideas and research and innovation. It's a place where things get incubated, and they're really excited about that, even how daunting the time is. That is what sort of gets me up in the morning, because I have, and some of them come from UC and researchers like you as interns or permanent workers. So that gets me excited to get up and do the work that I do.
And develop the next generation in the meantime.
Yeah.
Who else?
This is going to sound cheesy, but I hope after having listened to our champions today, you'll agree with me. It's our students. Like, our students are amazing. They are bright, they're excited, they want to make the world better. They're doing super cool stuff, right? That helps in so many ways, and just that the energy and the commitment and just the future, like the fact that I get to work every day to help each and every one of if you were a student on my campus, right? Just have an easier time and reach whatever goals or dreams you want to accomplish, and trying to make the university just a little less cold, a little less bureaucratic. Yeah, Berkeley takes bureaucracy to a whole other level. I think we're better than anybody else. Like the fact that I can still do everything I can to serve students and just make them feel seen, heard, and appreciated. That's what helps me get through.
Senator Dodd.
Yeah, well, I'm not totally retired. I'm retired from the legislature. And believe me, I'm not working anywhere near as many hours as I did, in the legislature. I find I mean, I've kind of been an absentee granddad, if you will. I've got 13 grandkids. And I've got kids that, working moms and dads. And so those of you that have gone through that or are going through that, I commiserate with you and if you're a grandparent, I commiserate because all of a sudden you wake up in the morning, there's a, different set of kids in your household in the morning. Okay, what are we going to have for breakfast here? But it gives me, or they're sick or, owies here and there. But it kind of gives me a fresh perspective on what's important in molding those kids into future stars like you. I mean, it's just amazing what the future holds. My other thing that, I've seen in don't mistake my comments here at all about being anti-government. I think we do so many great things, here in the state of California, local, our cities and counties. But I think there is a bureaucracy. There's a big bureaucracy in not allowing things that can happen. CEQA is absolutely one of them. In some way, somehow, helping companies get to a point where they're able to get things done efficiently. First of all, they shouldn't have to hire a company like mine to help them through that. It should be able to be done just by moving through the system. But it really is gratifying for me to be able to help people attain their dreams, and also to be able to choose which ones and how they operate honestly, ethically, and move forward in this tough world to run a business.
The last word, Dr. Wilson.
I want to know what's been discovered, what creative activity has been carried out from the day before by the fabulous UC Merced research community. My job is to help the researchers, and I get a lot of emails and people saying, hey, I need this thing fixed, and can you help me with that? But the administrative job is to help folks either achieve an opportunity or reduce some kind of an obstacle. So whether it's some piece of instrumentation that's broken, or it's some federal funding or foundation funding opportunity, that's my job, is to try to help the amazing researchers do their research and creative activities. So I want to know what they've done from the day before. I want to know what new discovery or creative activity has resulted in.
Well, we're reaching the end of our panel, but I do have one final question for you, and I want you to think about the ordinary people that you've encountered over the last couple of days, whether it's the grocery store person, the postal worker, a teacher, a farm worker, someone on a construction crew, a coder, an office worker. Why should that person care about research?
Because you run into it every day and you don't even know it. You're touching it when you open your phone. You're enjoying it when you're on YouTube. You're appreciating it in your doctor's office, you're experiencing it when you eat food or you have access to food that you wouldn't have had otherwise. You're touching it every day. You're the teacher in your school, the nurse in your hospital. Those are all people that benefited from having had the opportunity to do research and be part of a research community in order to make people's lives better.
And this is exactly what I was talking about earlier, the narrative, the talking points for this group that could go out and be a voice for research institutions, into our country and into our world. I would love to see a poll on what we saw the polls this last week. And if you watch any of the shows, I'm still on that on Sunday mornings. I'm sorry. I can't help myself. I just can't. It's terrible. But I would have loved to have seen the polling on what Americans feel about pressuring educational institutions to go beyond their values to get done what an administration wants. I think it would be the lowest polling of probably all the different items that we've seen. So I really think you're spot on there.
It's the societal impact. It's the quality of life that we all enjoy, whether we know it or not, because of the work that's been carried out. So, as you said, research touches everyone's lives, and we probably need to do a better job of conveying in all the ways research has touched their lives. But we need to think to the future too. Climate change is a reality. There are other potential natural disasters, like pandemics, and unless we invest in the necessary work, bad things will happen.
And Mr. Sefi, you have the final word.
I'll just end with what I started, which is that question, the relevance to that individual's life. I wish I had this question before. I met a woman in my neighborhood, young woman. I asked her what she's doing. She said she's passionate about tattoo and she's taking a class now. And I wish there was like innovation research on tattoo that could be relevant to her work. Asked her to research. Exactly. Yeah.
I think there's some skin research.
There's a math problem there.
There's a math problem there.
Relevance is important.
Yeah. Well, thank you. Please join me in thanking our panel. Director Acefa, Vice Chancellor Wilson, Vice Provost and Dean Garcia, and former Senator Dodd. Thank you all so much. I think the future of research is in good hands with our champions. Now, are we good? Yes, all right. So we now have a lovely lunch reception planned for you out in the hallway, but you have to return, that includes you, Mr. Alvarez, by 1:45 p.m. for the presentation of prizes. We're going to have Provost Newman and President Drake announce this year's awardees, including who will take home the Slammy, and also who will be our People's Choice Award. So enjoy the lunch in the lobby and follow the advice of our panel, mix and mingle. Talk to students, policymakers, our fabulous panelists, anyone and everyone you can. And thank you all so very much. We'll see you back here, 1:45.
These are the moments you have been waiting for. Welcome back to the Student and Policy Center in Sacramento, and to everyone watching us online. I'm Catherine Newman, the Provost of the University, and I want to add my appreciation and congratulations to all of the students for the extraordinary, impactful work that you're doing. You know, these are somewhat heavy times, but it is an extraordinary holiday for us to get to see the incredible work that you do. It gives us all a sense of hope and excitement for the future, because you really do represent the very best of the University of California and the best of what science has to give to all of us as people who need health care and need advice and comfort from all kinds of things that we need to worry about. So we thank you for that. Your work is inspiring. It's inspiring to everyone else. And you can see all of these amazing possibilities. With innovators like you, ready to tackle all of the problems that are most complex in the world, we can all have a great deal of hope for the future. Now, this is the part of the program you have all been waiting for, and when I get to be a little bit more popular, I was told to use my sing-song voice, my best Wicked energy, but I've never actually seen Wicked, so I don't know what that means. My loss. I'm pretty sure Broadway isn't calling for me anyway. So what you're looking for is for us to announce the awardees for this year's UC Grand Slam competition, and that's just what we're going to do. Well, it's almost what I'm going to do. First, I want to take a minute to acknowledge some very important people who are in our audience today, the graduate deans, who shepherd graduate education throughout the UC system, and it's their leadership that makes a day like this possible. And so I would like them to stand and be recognized for the work they've done to recognize you on each of the campuses and to make this competition come alive at every level. So we have Lisa Garcia-Bedoya, Jean-Pierre Delplanque, Jamie Smith, Brian Kite, Harachian, Lydia Kos, Judy Kim, Nikkei Blank, and Lila Rupp, and Peter Beal. Thank you all again for everything you do. All right, so we are going to announce the People's Choice Award, then a third place, then a second place, and the grand prize winner who will receive the Slammy. For those of you who don't know, the Slammy is a very distant cousin to the Grammy, part of a very prestigious award family, homegrown here at the UC. So stay tuned for that. All of you, of course, were very impressive, and we know this was difficult work for the judges. I'm glad I wasn't one of the judges either. In fact, the Office of the President wants to be sure that every single student participating is acknowledged today. So anyone who does not receive one of these 4 cash prizes will be awarded a $500 token of approval and appreciation for your thoughtful work and your commitment to research. So let's start off first with the audience judges. That's all of you. Our thanks to everyone who took the time to text. We can now announce the system-wide People's Choice Award. Ta-da! This says Kelly is supposed to do that, but I guess I'm gonna open it anyway. Oh my gosh, it's a golden envelope in it. You wanna be Vanna? Okay. He gets to see who it is first. Adekunle Adewole is UC Merced. Congratulations to Adekunle and to the Dean at UC Merced.
Great, fantastic.
Adekunle, do you want to hold this? Whoops. There you go.
Thank you.
You're welcome. All right. So next we have the third place winner, which goes to, do you want to do this? Or you want
I'll let you be a single.
Okay. The envelope, please, goes to Angeliz Vargas Casillas, UC Riverside. And her dean, Lydia Kos. That should pay off some of the rent you were talking about. All right, then we have the second place winner. Goes to Yara Khatib from UC Davis. And Jean-Pierre Delplanque is the dean. Wow. Yara. All right. And then we have the UC system-wide Grand Slam champion, first place winner. The Slammy goes to, this is very tightly wrapped up, I want you to know. And I'm not making a very pretty job of it because we're trying to rip this envelope open and get you the answer. Yes, we need a drum roll, please. First place winner, Sophia Miliotis, UC San Francisco. Do you have another hand? If you don't, I'll. Okay. This, as you know, is an annual competition. And so we always have a perpetual plaque for a dean. I'm going to tell you which one in just a moment. This is an annual competition. And the dean gets to hold this plaque, and it goes to UC San Francisco, Nikkei Blank. Okay? Woo-hoo-hoo. There's something for your wall. President Drake should have a picture with you, though. So the dean's name will be added to this plaque, and she gets to be the proud holder of it for the next year. Let's have a round of applause for everybody. On behalf of everyone involved, my colleague, President Drake, all of us in the Office of the President, everybody who worked so hard to organize this, Yvette and her staff, extraordinary people who make this happen every year. A special thanks to the governor's office and the state legislature and all of the personnel that work so hard to move the state of California forward. It's really a pleasure to partner with you in making this state the brilliant place that it is. Keep it up, people. We expect to see you in the classroom, in industry, as leaders of your field, and all of us are going to benefit from your discoveries. Thank you so much.